Good morning, class. Today we're dealing with section 4 of our review chapter, and the title is Slope and Linear Functions. The objectives this section are to find and interpret the slope of a line, graph equations, which are the form y equals c or x equals a, graph other linear functions, and to be able to find the equation of a line if you're given certain characteristics, such as the slope in a point or when you're given 2 points. And then we're going to be solving applied problems involving linear functions at the end of this section. Let's get started. The first question asks us to find the slope when we're given 2 points. So let's first recall the formula for slope. The formula for slope is the difference in y's over the difference in x's. In other words, y2 minus y1 over x2 minus x1. We know it as rise over run. I like to put arrows to go up and over to the right so that we can always recall which direction we're supposed to go. It doesn't matter which point you consider x1 or y1. It just matters that you are consistent. So let's call our first point x1, y1, and our second point x2, y2. And so to set this up, I would get -1 minus 5 over 6 minus -3. And you have to be careful that when you put this up, you put parentheses around any negative numbers that follow a minus sign. So I get -6 over 6 plus 3. That's -6 over 9, which you want to reduce, and we're going to call that -2/3. So my slope is -2/3. For this next question, we're asked to graph y is equal to -2. And if you don't remember, the y equal equations graph horizontal lines. But if you don't recall it, we can always do a t-chart. No matter what value I pick for x, my value for y is going to be -2. So we can pick any value we want for x, but we still get -2 for our y. So let's graph those points. You get to 1, -2, 2, -2, 3, -2, and you can see that no matter what, we're going to get y values of -2. So we should have a straight line that's horizontal. Recall that a line should go from edge to edge of your graphing window. It's also helpful to put arrows on the end of each line. And so there we go. We do want to label it. And you don't have to label each line, you just have to label it enough so that we can tell what your graph is doing. And when we look at this slope, what we could do is just pick 2 points. Let's pick this point and that point to put into our formula. We'll say our slope is -2 minus -2 over 3 minus 1. And when we simplify that, we get 0 over 2. In other words, our slope is 0. We skipped over the B part of this question, so let's answer it now. It says to decide whether the graph represents a function. And when we look at this, we do the vertical line test, and any vertical line that I draw only intersects this line once. So therefore, it passes the vertical line test. Yes, it's a function. So you want to remember to answer that question as well. Let's move on to example 3. Example 3 asks us to graph a line that is x equals 4. And if you don't recall, x equal equations graph vertical lines. Let's go ahead and draw our t-chart. And on this t-chart, we will put any value we want for y, but then the x will always be 4. So we can put all these values and we can fill it in however we want. But if I fill it in, my x value will always be 4 because that's the equation. Let's graph those points. So I'll go to 4, -1, 4, 0, 4, 2, 4, 5, and all of these points draw a vertical line. Once again, making my line extend from edge to edge of my window and putting arrows on each end. Let's go ahead and label the chart as well. So there we have it labeled. I'm going to go ahead and do the line slope first. So let's just pick 2 of the points. Let's pick 4, -1, and let's pick 4, 2. just for fun. And so to find the slope, we're going to say 2 minus negative 1 over 4 minus 4, which becomes 3 over 0. And if you recall, something divided by 0 is undefined, so we cannot do that. We have a slope that's undefined. What do I do with an undefined slope? Well, that's about it. We can't define it because we can't divide by 0. Now let's go back and decide whether this graph represents a function. Remember, we did the vertical line test, and when I do this vertical line test, this vertical line basically intersects this graph everywhere. More than once, definitely more than once. So this is not a function. And because it's not a function, and we see that the slope is undefined, we can sort of correlate that a little bit. Whenever we have a function, we should be able to tell the slope of a line. And if we're not able to tell the slope, if it's undefined, then we know it's not a function, because then it would draw a vertical line and it would fail the vertical line test. We have more than one output for every input 4. All right, moving on. Question number 4 is a word problem. Let's read it. The weight M of a person's muscles is proportional to the person's body weight W. And so when we read this question, we see the word proportional, and proportional questions are questions that can be graphed with a line, with a slope, and a y-intercept of 0. So we know we can use M for the slope, and we have little m for the slope and capital M to show the weight of the muscles. Let's look at the first part of the problem. It is known that a person weighing 200 pounds has 80 pounds of muscles. Find an equation expressing M as a function of W. That means that M is going to be isolated on one side, and then the mathematical expression is going to have the W as its variable. So let's go ahead and write that. I would say capital M for muscles is a function of W, and we're going to have our slope multiplied by that weight. And in order to figure this out, we want to put in the information. 200 pounds is a person's weight. That's going to be our W. 80 pounds of muscles. That's going to be the weight of the muscle, so we're going to use M there. Let's put that into our formula. We have 80 is equal to M times 200. And let's solve for M by dividing. And then reduce. So that'll be 8 over 20, and reduce by 4, we get 2/5. And now that we solved for our M value, we can plug that back into our original generic equation, and we're going to get M is equal to 2/5 times W. Whenever we're given a situation in the beginning, we use that situation to figure out any other variables that we want. So we started off with an equation that had 3 variables in it. We knew a situation which gave us the muscle weight and the total weight, and so then we could solve for the slope. After we solve for the slope, then I come up with my formula expressing my muscle weight as a function of my body weight. We're then asked, what's the muscle weight? So we're trying to find M. When the person weighs 120 pounds, that is their body weight. We're going to take that and put that into our formula. So we get M is equal to 2/5 times 120. And using my calculator, I got 48. We want to make sure we have the correct units. Let's go back to where we see it talked about. We see the units of muscles was in pounds. So I'm going to say 48 pounds of muscles. You always want to make sure you use the correct units, referencing a previous section. So let's go over the steps one more time. We started off with a generic one. After that, we had the generic formula. We plugged in values from our word problem situation to solve for M. And once I found out the value of M, then I was able to come up with my equation. After I came up with my equation, then I could plug in the last situation to find out how many muscles. So it's sort of a 3-step problem to be able to answer this. Setting up word problems is not a skill that most people have. So it's really important that you practice this. So pause the video now and then go do the book example. For question number 5, it asks us to find the slope and the y-intercept of the graph of the line 8x is equal to negative 12y plus 6. Now we know how to write an equation in slope-intercept form. The problem is that this question is not written in that format. So we want to isolate the y and move it over to the one side and then put all the other terms on the other side. That way we can take out the information that we need. So I just like to add 12y to both sides to get the y on the left. Because those aren't like terms, I can't combine them. So I do need to rewrite this and leave them as separate terms. Now I'm going to move the 8x away, so I'm going to subtract it from both sides. And that gives me 12y is equal to negative 8x plus 6. And then I'm going to divide everything by 12. I chose to divide everything by 12 so that my y would be isolated with a coefficient of 1. And then we have to reduce these fractions. And there you go. The coefficient of the x is our slope, so we'd say m is equal to negative 2/3. Don't be tempted to say negative 2/3 x, it's just the coefficient portion, so it's just the negative 2/3. And then our y-intercept is 1/2. And there we go. We've answered the questions that they've asked us to do by rewriting this in slope-intercept form. We're moving on to the next objective, which states that we should be able to find the equation of a line given certain characteristics. The characteristics that we have for this equation is that we know the slope and we know a point. So we should be able to use the point-slope form to be able to come up with that equation. So there's the point-slope form of a line, and we want to identify the parts. We're given the slope as 1/4, and we're given the x1 and the y1 in this point that we have. So we can replace that information, say y minus 3 is equal to 1/4 times x minus negative 8. And then you just want to simplify that. Making sure that you turn that to a positive when necessary. You want to distribute the slope. And 1/4 times 8 is 8/4, or just 2. And then adding 3 to both sides, we would get 1/4 x plus 5. Now technically, we were done at this step. That is an equation of the line with the slope and the point. However, typically we want to write it in slope-intercept form. And so that sometimes might be misleading to you. You might hear the instructions say, find the slope-intercept form of a line. And they mean they want it in this format, but you can't put your information directly into that format. You have to use the point-slope formula to put your information into it, and then you can simplify and rewrite to get to the slope-intercept form. Another mistake I hear is that students will call this the slope form of a line. Notice slope is in both of those titles, so that's not very helpful. You have to make sure you say point slope or slope intercept. Those are the two formats that we're using. Okay, and we're moving on to the next example. For question number 7, we're asked to find the equation of a line containing 2 points. Let's recall the two formats of equations that we know. We know slope-intercept and point-slope formats. However, both of these depend on finding the slope, which we weren't told. However, we do know how to find the slope given 2 points, which we have, and that would also give us the point to use the point-slope formula. Let's go ahead and find the slope first. Writing down the formula, let's figure out which point we'll use. Now that I've labeled them, I can put those into my formula. I'll have negative 7 minus negative 1 over negative 8 minus 4. And that gives me -7 plus 1 over -12. And -6 over -12 is positive 1/2. So now I know my slope is positive 1/2. I can use that, and I can use any of these points to come up with my equation. Writing my point slope formula, I know my m and my x1 and y1, so that makes it easy to plug in these values into this equation. We'll do y minus -1 is equal to positive 1/2 times x minus 4. We'll multiply that out and distribute that negative. We get y plus 1 and 1/2 x minus 4/2, which is going to be simplified to 2. We'll subtract 1 from both sides, and then we get y is equal to 1/2 x minus 3. Once again, we were technically done at this line. This is in point slope format. But it's not until we simplify it and write it in this format for the slope intercept format are we able to answer the other questions that are asked. It asks us to determine the line's y-intercept and express it as an ordered pair. The y-intercept comes from this portion of it. So my y-intercept is -3. And if we want to write it as an ordered pair, we would actually say 0, -3. And so those are our two answers to both questions that are asked in question 7. This next question and the one following it are applications of linear functions. We are given a situation which we want to come up with an equation to describe, and there's going to be times that you do this, including in the homework section, but you will have usually some fixed costs and some variable costs. And the fixed costs are usually what happens when they say, before you begin, this is how much you need to invest. This is what your initial costs are before you start doing anything. This is what we call fixed costs. And so I'm just going to label it F. And it says here that our fixed costs are $10,000 per year. This doesn't change. That's how much it costs no matter what. And then it says to produce X units of a certain kind of suit, it costs $20 per suit. And when you see something that says 20 per suit, then that means that you're multiplying. So my variable costs are going to be $20 per suit. And notice that per suit talks about how many units. This is X, that's where we're using it. The total cost of producing suits is going to be the variable cost plus the fixed cost. And that's what they came up here with 20x plus 10,000. We're asked in part A to graph the variable cost, the fixed cost, and the total cost functions. So on my next page, I'm going to graph f of x, v of x, and c of x. So we're asked to graph these three functions. Notice that the numbers are fairly large, so when we label our graph, we want to make the numbers accommodating to the types of data that we have in this. The labels on your x-axis and your y-axis might not be spaced the same for both axes. You might have different scales, but you have to make sure that on each axis individually that the scale makes sense. So notice that my gaps between my numbers on my x-axis have a gap of 100 each, but the gaps on my y-axis, that's 10,000. So that's not the same scale. However, it should make sense for each axis that you're talking about. It also helps to label them. Since x is how many suits we have, we're going to put that on the x-axis. And then the y value is going to be our cost, so I'm going to label that. It's always helpful to put the correct units on each axis. Now the easiest function to graph is our constant one. That would be f of x is equal to 10,000. So at $10,000, we're going to put a horizontal line. And there we go, we've graphed f of x. Let's go ahead and put some numbers in to find out the graph of our variable cost. 20 times 0 is 0. 20 times 100 is 2,000. 20 times 500 is 10,000. So I get the 0, I get the 10,000. We would connect them with a line. Now notice how my graph doesn't start and it doesn't cross the x-axis over here. I'm not putting any information there because it doesn't make any sense to have negative values for costs, or it doesn't make any sense to have negative terms of suits produced. So the domain of this would start at 0. We're going to go 0 and to positive numbers. So we're not going to put that line there. We do want to say it does extend in that direction. We can do the same with our green graph as well. We started right here at the 0, and then we continue on in this direction to the right. Let's just plug the same numbers in. When I plug in 0 to c of x, I get 10,000. When I plug in 100, I get 12,000. And when I plug in 500, I get 20,000. Let's graph that. 10,000 to 20,000. And there's our graph of c of x. For part B of this question, we're asked what is the total cost of producing 100 suits. That's asking us what is c of 100. And that would be 20 times 100 plus 10,000. So 2,000 plus 10,000. The total cost would be $12,000. And make sure you put your units on that. What's the total cost of producing 400 suits? Well, that would be finding the total cost of 400, plugging that into our equation. That would be $18,000. Making sure, once again, to put your units on all of your answers whenever we have a word problem. We just calculated the cost to produce suits for this business. The next problem we're doing is going to go on to finding the revenue and the profit and the break-even value for the same situation, adding more functions to our mix. Moving on to the next question, we're talking about revenue first, and the total revenue that a business receives is the product of the number of items sold and the price paid per item. That means we're multiplying them. Thus, if they're selling X amount of suits at $80 per suit, then that's $80 per suit, meaning multiply. We're going to get $80 is our unit price times X amount of suits sold. So our R of X function is 80X. Our C of X function was already discovered on our previous question, and we are asked to graph them on the same set of axes. We'll fill in our T-chart to help us out. If I sell 0 suits, I'll make $0. If I sell 100 suits, I'll make $8,000. And if I sell 200 suits, I would make $16,000. And that's enough to graph. So we'll go to 0, 0, 100 and approximately 8,000, and 200 and approximately 16,000. As straight of a line as you can draw. You want to graph that. So there's our R of X function. Once again, we don't want to go beyond to the negatives on the x-axis, so we're going to start our graph right at the 0 and then make it our domain only in the positive numbers. Total profit is the amount that the business receives after all costs have been subtracted from the total revenue. So if we're using P for profit, P of X will represent the total profit when X items are produced and sold. We have basically, the formula is revenue minus costs. So we had our revenue function, and we're going to subtract the cost function. Alright, and so we have that. Let's go ahead and simplify that. We would have 80x minus 20x plus 10,000. Make sure you use parentheses to keep everything together, because you'll simplify that to become 80x minus 20x minus 10,000. So our total profit would be actually 60x minus 10,000. We're asked to graph that on the same axis, so I made a T-chart. Plugging in 0, we would get negative 10,000. Plugging in 100, we would get 6,000 minus 10,000, which is negative 4,000. Plugging in 200, we would get 12,000 minus 10,000, which is positive 2,000. And we could continue with this. Plugging in 300, we would get 18,000 minus 10,000, which is 8,000. And we can graph all of these. We had to extend our y-axis to get into the negatives, so we're going to start in debt. Having graphed it, we can see that it goes through the points that we said it would. It's going through 100, negative 4,000, 200, positive 2,000, 300, positive 8,000, and keeps on going up until here. So we have our cost function, our revenue function, and our profit function all graphed on the same axis. Notice that our cost is greater than our revenue at the beginning because we had the initial cost. And so over here, we have what we call a loss. When we have a loss or where we're in debt, we usually say we're in the red, so I highlighted that in red. But then when our revenue exceeds our cost, that's when we start making some profit. And notice that our profit function turned positive at the exact same time. And so we typically say we're now in the black, which means we are making money. Another word for that is our gain. Now the break-even value of x is the value of x for when my profit is 0. That is, when p of x is equal to 0. Or in other words, when my revenue is equal to my cost. Because when they're equal to each other and they subtract each other, that's when you get 0. So what is the x value here and here? It should be the same x value when that happens. We can solve it by setting r of x equal to c of x, or we can solve it by setting p of x equal to 0. So I set it up as 80x is equal to 20x plus 10,000. And letting our calculator do the work, we would come up to about 166.6 suits. Maybe 0.67. So we have our break-even point around that time. I would be in the red if I sold 166 suits, and that's it. But I would finally make a profit if I sold my 167th suit. So that's how you read those numbers. You will be having lots of questions about profit, revenue, total cost, cost functions. And so you want to be familiar with these terms. You want to be able to use them, to graph them, to understand what break-even points are, and to understand what their relationship is to each other. And hopefully this makes sense. And as you get the practice on the homework, you'll become a pro at it. All right, that's it for this section and for the week. Thank you and have a good day.